بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. I would like to welcome my students from grade 12 in Hadda Valley School into their first online lesson in chapter 4. So in this lesson we will start with chapter 4, which is going to be about conic sections. And in this lesson we will take the first of the 4 different conic sections. Now, conic sections are mainly 4 shapes, and these shapes are the circle, the parabola, the ellipse, and the hyperbola. Now, this chapter is going to be the only chapter you have in geometry, and you will concentrate your study on these 4 shapes: the circle, the parabola, the ellipse, and the hyperbola. And in this lesson, the first lesson, we will see the first of these 4 shapes, which is the parabola. Actually, this chapter is going to be divided into 2 lessons. This is the first of which, and in the second lesson we'll talk about the 3 other shapes because they look too much similar to each other. So, the first question that might come to mind is, what is the parabola? And to do that, we will need to define the parabola. But before that, let's see the objectives of this lesson. Now, the objectives of this lesson are the following. By the end of this lesson, you should be able to write the equation of a parabola using its focus and its directrix. And we will learn what are these in a while. You will be able to write the coordinates of the focus of a parabola in standard position given the equation. So you will be given the equation and you will be asked to write the focus. Also, you will be able to write the equation of a directrix of a parabola in the standard position given its equation. So they will give you the equation of the parabola and they will ask you to find the equation of the directrix, and you will be able to write the equation of a parabola that is not in a standard position. Now, this lesson is usually easy. It's not that hard. Most of it is actually easy, and we will see this now. But before we start again, we will need to define what the parabola is. So we will start with a definition. So we can say that the parabola is the following. The parabola is the locus of a moving point whose distance to a fixed point called the focus equals to its distance to a fixed point, to a fixed line, which is called the directrix. Before we start with the definition, we would like to elaborate a little bit on the word locus. Now, locus, you can understand this word as path. It's the position as well. Position or a path. So, the parabola is defined as the path. The path that is taken by a moving point. Okay? So you will have a moving point, a point that moves, okay? Whose distance to a fixed point. So we have a moving point here, and we have a fixed point. A fixed point means that this point will not move from its place. And we will call this point the focus. So this point, which does not move from its place, is called the focus. Now, they say that the distance to the focus, this is the distance between the point and the focus, this distance, equals to its distance to a fixed line. So you'll, in the other side here, you will see a fixed line, and this fixed line is called the directrix. And the distance in this side is equal to the distance in this side. And then, so for example, this is D1, this is D2, you will find that these 2 distances are going to be equal. And then this point is going to start moving, and while it's moving, the distances will always be equal to each other. They will not be the same. They'll not be the same as the beginning. They will increase, but while they are increasing, they will be equal to each other. Let's see this in a more graphical way. Now, let's look at this graph. Now, in this graph, let's have a look at these points now in front of us. Now, let's say that this is the focus. This is a fixed point at 4 and 0. And let's say that this is the directrix. This line is the directrix. And this line is x is equal to -4. This is the equation of the directrix. Now always remember, I think some of you might remember this from last year. We said that points are defined by coordinates. So when you have a point, you must have coordinates. Lines are defined by equations. So when you have a line, you must have an equation. So this is a point. The coordinates are 4 and 0 because it's 4 from x and 0 from y. This is a line. The equation is x is equal to -4 because it cuts the x-axis at -4. Now let's say that this is the moving point. This is the point B. Point B has a distance to the line that is equal to 4 units and to the point that is equal also to the 4 units. It's here. So this distance is 4 units and this other distance is 4 units. Now what we desire to do is we want to move this point now, but while we are moving it, we want this distance and this distance to be equal to each other. We don't want them to remain the same as 4. No, they will increase for sure. But we want them to be equal to each other while we are moving. So let's try to do that. I'm going to take this point now and I'm going to start moving it. Now, if we move it a little bit upwards, you see now the distance is 4.06 and here also 4.06, right? So the distance is equal and the point has moved from 0, 0. Now it might seem like it moved vertically, but actually it did not. Let's show you. I'm going to move further. Now do you see where the point is? The point has started becoming closer to the direction to which the focus is and further from the directrix, but the distance is the same. The distance is 4.24, 4.24. Now let's move it even further. Now do you see? 4.62, 4.62, and the point is moving. It's trying to enclose the focus. It's like it's rotating around the focus. Now, if we keep doing this, we are going to create a path. These blue dots are the path. This is the locus. So this is the locus of a moving point whose distance to a fixed point, which is the focus, equals to the distance to a fixed line, which is the directrix. This is the definition of the parabola. The parabola is these points. This place is called the parabola. Now, if we keep moving it, we're going in both directions, we're going to form what is called a parabola. So this is now, this shape is the shape of the parabola. And we can show the parabola itself. So the parabola itself is going to look like this. Eventually, it's going to look like this. Now, this is the shape of the parabola. Now, any point, look, if it was even here, any point on this parabola has a distance to the focus that is equal to the distance to the directrix. And this is how the parabola looks like, okay? Even here, the distance is 47.57 and the distance here is 47.57. They're exactly equal to each other. So again, this is what we call the parabola. Now, I hope that you have a better understanding of the definition now. So let's come to the definition. The definition says, the parabola is the locus or the path of a moving point whose distance to a fixed point called the focus equals to its distance to a fixed line called the directrix. Now, guys, you will need to memorize the definition actually, because in many years, students were asked to define the parabola. Of course, this year you don't have direct questions, but they might give you a definition and they will ask you, what is this definition for? Is it for a parabola? Is it for an ellipse? Is it for a hyperbola? Or is it for a circle? Because we have 4 different shapes. Okay, let's move on. Now, there is an important thing that you need to understand before we move on into the lesson. Parabolas have what we call standard positions. Now, what do we mean by standard positions? Look at this, guys. Now, there are some conditions at which we can say that the parabola has standard position. Let me show you these conditions first before I go to the graph. Look at this. We say that the parabola is said to be in standard position if one of the following is true. Now, look at this. if the vertex is the origin and the focus is one of the two axes. What do we mean by that? Let's go to the graph. Now, if I show you the parabola here, this point right here, this point is where P is at right now, where B is at right now. This point is called the vertex. This point is called the vertex. So we have a vertex here. This is the focus. This is the directrix. These three names are important, very important in this lesson. Again, if we show them here in a sketch, now you will always have a parabola, for example, like this, okay? This point is called the vertex. So here, this is the vertex. The focus is going to be enclosed inside the parabola. This is the focus. And the directrix is going to be just in the other side, right here. This is the directrix. Now when do we say that the parabola is in a standard position? If one of the following happens. If the vertex is in the origin. What do we mean by the origin? We mean by the origin the point 0, 0, the origin of the graph. And the focus is on one of the two axes. So it is either the focus is on the x-axis here, or the focus is on the y-axis here. Let me show you how now in the graph. Now look at this. I'm going to remove the parabola and show you the points. Now we call this a standard position. Why? Because the vertex is at the origin. You see the vertex is at the origin right now, and the focus is on the x-axis. Now, wherever I move the focus here, wherever I move the focus, this is going to be still a standard position, even if I move the focus to the other side, to the negative x-axis. Do you want to see the parabola now? The parabola will look like this. Okay? So this is going to be also a standard position. Now, even if I move the point on the y-axis, now even if the focus is on the y-axis and the vertex is at the origin, you see the vertex is at 0, 0, and the focus this time is on the y-axis. Even if we choose a different point for the fixed point, even if we fix the point here, or we fix it here, or we fix it there, now you will always get a parabola in the standard position. This is now a standard position. And also, even if you move this in the opposite direction, in the negative direction, as long as the focus is on one of the axes, and as long as the vertex is on the origin, we say that this is a standard position. Okay, it has to be both of them though. So they have to tell you both things. They have to tell you that the vertex is at the origin, and they have to tell you that the focus is on the one of the two axes. In this case, you know that this is going to be a standard position. And be careful, guys, because sometimes you will have some parabolas, but they will not be in standard position. And you have to differentiate between the two cases, because it's going to be different while you are solving the question. So the parabola is said to be in a standard position if one of the following is true. This is the first case. The second case, okay, let's erase what we did before. So the second case is the following. We say that it's a standard position if the focus is on one of the axes, okay, but we don't know about the vertex. We know this time about the directrix. So if we know where the focus is, and we know that the focus is one of the axes, and the directrix intersects the same axis in the exact distance from the opposite direction. Here, look, if we don't know where B is, if we don't know where the origin is, the vertex is, I'm sorry, if we don't know where the vertex is, but if we know that the focus is here, look at 0 and -7, so it is on the y-axis, and we know that the directrix is y equals 7, so we know that the directrix cuts the y-axis and the point also on the y-axis, because we have a y value. We don't have an x value. The x value is 0, the y value is -7, so we know that it's on the y-axis. And the directrix is also on the y-axis because it's y equals. And the number that we have here, 7, is the opposite of -7. So if this is true, if you know the focus and you know the directrix, and you know that they are on the same axis, and they have different values, opposite values, not different, opposite values, then in this case, you know it is also a standard position. This happens wherever you move. Notice that wherever I move the fixed point, the focus, the directrix will move accordingly so that our drawing is going to be a standard position. The same thing if it's on the x-axis. Now look at if it's the x-axis. Now if it's on the x-axis, you see this is -9 and 0. So it is on the x-axis because it has an x value. The y value is 0. And on the other side, we have the directrix at x is equal to 9. The equation is here on top. X is equal to 9. This number is exactly the same as this number, but with opposite signs. So, and it's x, it's not y, huh? It's x. Before it was y equals 7. This is x. Why is it x? Because we have an x value this time, not a y value, because it's cutting the x-axis. So if this is the case, if your focus and your directrix are on the same axis, but they're exactly at opposite sides, then you know that this is a standard position. So we know their standard positions by two things. Either the vertex and the focus, or the directrix and the focus. Either the vertex and the focus, or the directrix and the focus. So I should always have two givens to know if it's a standard position or not. Okay? All right, so let's investigate a little bit about more about standard positions. Now look at this, guys. I have shown you the first parabola, which looked like this. This is now called the standard position number 1. This is standard position 1. Okay, this is how it looks like. The parabola always going to enclose the focus, and it's going to enclose the focus and be concaving towards the positive x-axis. Okay, now the equation of the parabola, because look, the parabola is a line, and as we have agreed with you before, points will be described using coordinates. Lines will be described using equations. So the parabola is a line, and it should be described using an equation. So let's see the equation. The equation of this parabola is going to be y squared equals 16x. Okay? Now notice that the focus is at 4. The equation is y squared equals 16x. I'll show you how to find this equation in moments now. But notice what happens to the equation if I change the focus and therefore the directrix. Look, if I take the focus to 3, the equation is still the same, y squared equals, but this time I have 12x, not 16x, but 12x. And the focus is at 3. If the focus is at 2, y squared is equal to 8x. If the focus is at 1, y squared is equal to 4x. If I move further, at 5, for example, y squared equals 20x. So what do you notice? It's like this number, y squared is always there, x is always there, but this number, the 5, is actually multiplied by 4 and we get 20. If it is 4, we will multiply it by 4, we'll get 16. If it is 3, I'll multiply it by 4, I will get 12. Do you get that? If it is 6, I'll multiply it by 4, I will get 24. So it's like this number before the x is the same as the focus, the value of x in the focus multiplied by 4. This is called the first standard position, or standard position number 1. Is this the case with all the standard positions? Actually, it is. Look, if we move it to the second standard position, now this is the second standard position. Do you notice what's happening now? We have a negative 32 at negative 8. So multiply negative 8 by 4, you get negative 32, right? We have a negative 7 and negative 28. So it's multiplied by 4, you get negative 28. We have negative 6, and here negative 24, which is multiplication by 4. We have negative 20 now. We have negative 16, negative 12, negative 8, negative 4. So it's the same case even if it is the second standard position. In the second standard position, notice that the focus is negative, the directrix is positive. In the first standard position, the focus was positive and the directrix was negative. And the equation is always 4 times the number in the focus, not the number in the directrix, the number in the focus. So the number is 7, 4 times 7. The number is minus 7, 4 times minus 7. And you have y squared equals minus 28x. So let's look at these two standard positions first. So the standard positions are going to be summarized in this table. We have seen so far the first standard position and the second standard position. The vertex in each one of them was the origin, 0, 0. The focus here was C and 0, here it was minus C and 0. So we had minus C here and we had C here. So the number was in the positive x-axis and there the number was in the negative x-axis. Remember, if it's the standard position is the first standard position, then the focus is here. So it is something from x and 0 from y. But if it was in the second standard position, the focus is here. So it is minus c and 0. The directrix is going to be in the opposite direction. So the directrix is going to be here at x equals minus c, and also here at x equals c. The equation is going to be 4 multiplied by c, because we have c here, multiplied by x. The second one will be 4 multiplied by negative c, because we have negative c here, multiplied by x. So y squared equals 4cx, and y squared equals minus 4cx. These two now are called the standard positions, number 1 and number 2. Now we will see the third and the fourth standard positions as well, just right now. Now notice that in the third and the fourth standard positions, my point has a y value, it does not have an x value. So our parabola, our focus is going to be on the y-axis, not on the x-axis. Let me show you now. So this is now called the third standard position. The focus is on the y-axis and the directrix is cutting the y-axis. And this is here the fourth standard position. So it is in the negative side, in the positive side. Do we still hold the same relationship? We will just multiply by 4? Yes, you just multiply by 4. But this time, notice that it's x squared equals minus 24y. Because it's minus 6 times 4. And why is it multiplied by y? Because this point is on the y-axis. Same thing here. It is 12y. 3 times 4, which is 12, and then why is it multiplied by y? Because this point is on the y-axis. The other variable is going to be squared on the other side. Now notice, when we had equations from the first or the second standard positions, it was multiplied by x. Why? Because the focus is on the x-axis. This is actually negative x. It means that the focus is in the negative x. And if it is a positive x, it means that the focus is in the positive x. Now, if you have a positive y, it means that the focus is in the positive y. And if you have a negative y, it means that the focus is on the negative y. So the third and the fourth standard positions will have the same vertex. The vertex must be 0 and 0 in all the standard positions. The focus is 0 and c, not c and 0, no, 0 and c, 0 and minus c. The directrix is the opposite, but it's not x, it's y. So it is y equals minus c, y equals c, because this is a y value and this is a y value and y. Here it's x value x, x value and x. The equation is x squared equals 4cy. Why is it 4cy? It is positive y because the third standard position is in the positive y-axis. And this is a negative y because the fourth is in the negative y-axis. Now, if we can look at the 4 standard positions, so this is the equation of the first. It's a positive x. So notice that the focus is in the positive x-axis. And the parabola must enclose the focus. The second standard position is in the negative x. So notice in the negative x, the focus is on the negative x-axis right here, and the parabola encloses the focus. And the third standard position is in the positive y. So the focus is on the positive y and the parabola is enclosing it. And the fourth one is in the negative y, and so the focus is in the negative y and it's enclosing it, and it's always multiplication by 4 by the point of the focus. Okay? So let's see some exercises now. Okay. First says the following. Find the equation of the parabola. So they want us to write the equation of the parabola. Just to show you the equation of the parabola here, this equation, or this equation, or whatever equation, okay? So they're going to give us something and some givens, and they want the equation of the parabola. So find the equation of the parabola that satisfy the following conditions. The first one, the vertex is 0, 0, and the focus is 0, 6. Okay. Now, whenever you want to solve such problems, it's always good to have a little sketch of it. So you're going to sketch what's given to you. The vertex is 0, 0. It means the vertex is at the origin. The focus is 0 and 6. So 0 from x and 6 from y. It's here. 0 and 6. Okay? So is this a standard position? Yes, it is. Why? Because the vertex is at the origin and the focus is on the y-axis. How does the parabola look like? The parabola looks like this. It's going to be enclosing the focus, right? They want us to find the equation of the parabola. Well, it's easy this time. How? This here is going to be c, so c is equal to 6. Okay? And we know that the equation of standard position 3 is the following. It is x squared equals 4cy, because we are going to have the positive y-axis. So the positive y-axis multiplied by 4c, and here we have the other letter squared. So c is 6. Just substitute 6 in the place of c. So x squared equals 4 times 6 times y. So x squared equals 24y. This is now the equation of the parabola. I think this cannot be easier than that. Okay? So just take the point at C and multiply it by 4. Now look at this, guys. You might have a question like this as a multiple choice question. It's quite easy. Just write the vertex and the focus, and I will give you some choices as the equation of the parabola. I hope that this one is clear. Let's move on to the second question. Find the equation of the parabola that satisfies the following conditions. The vertex is at 0, 0, and the focus is at -3 and 0. This is also quite easy. Look at this. So here the vertex is 0, 0. So this is the vertex at 0, 0. And we have a focus at -3 from x. So here, at -3 from x and 0 from y. And the parabola must enclose the focus, so the parabola should look like this. Which standard position is this? This is the standard position number 2. The first one is to the right, the second to the left, the third up, and the fourth down. So this is the second standard position because the parabola is concaving to the left. So this is SP2. Okay? How much is the value of C? Now, some of you would say that the value of C is -3, but I will argue that the value of C should always be taken positive. Always take C as positive. Why? Because in the rules we have the negative. The negative is going to be provided in the rule. How is that? Look at this, guys. Do not my point is, yes, this is -3, but do not say that C is -3. This is actually -C, comma 0. If you look at the table before again, so the table here says, not this table, okay, it says -C. So if you have negative 3, so C is 3. This negative is this negative. And C is equal to 3. So when you find the value of C, just say it is the positive value, not a negative value. So here C is actually equal to 3. And why do we say that? Now the equation should be the following. It should be 4 times C, right? And because this is in the negative x-axis, so I'm going to multiply by the negative x, and the other letter is going to be y squared. So the equation should look like this. You can go back to the table and check that this is the equation in SP2. So y squared equals minus 4 times 3 multiplied by x. Now this is why I told you take C as positive, because if you take it negative times negative, it becomes positive. So you'll have a different standard position, which is going to be wrong. Just take it as 3 and multiply it by the negative from the equation. So y squared equals minus 12x. This is going to be the equation of this parabola. I think it's quite easy. Let's move on to a third example. So here it says find the equation of the parabola that satisfies the following condition. The vertex is 0, 0, and the equation of the directrix is y is equal to 2. Again, it's always best to draw these first so that we can get an idea about the parabola, how it looks like, which standard position it was going to be. The vertex is 0, 0. So the vertex is right here. Good. And the equation of the directrix is y is equal to 2. So y is equal to 2. From the y-axis, this is y is equal to 2. Y equals 2. Okay, if this is the vertex and this is the directrix, where will the focus be? Yes, the focus should be in the opposite direction on the same axis, so it's here. It will be 0 from x and negative 2 from y. And how does the parabola look like? It's going to look like this. It's going to enclose the focus. So this is going to be a standard position number 4. And by the way, guys, this is 0 and negative c. This is also c. So how much is c? C is equal to 2. So as long as it's the standard position number 4, this is how we write the equation. I'm going to multiply 4 by c. And because the focus is on the negative y-axis, I am going to multiply by negative y. And this is going to be x squared. So this is the equation of the parabola in the 4th standard position. So x squared equals minus 4 times 2, which is minus 4 times 2, y, which means eventually that this is x squared equals minus 8y. This is the equation of the parabola. Okay? I trust that this is quite easy. When parabolas are in standard positions, they're usually easy. Let's take another type of questions. This type says, find the coordinates of the focus. So this is what they want. They want the coordinates of the focus. Remember that the focus is a point. So whenever they want a point, they want the coordinates of that point. And the equation of the directrix, this is a line. And whenever we have a line, we need the equation of the line. And then sketch the parabola in each of the following cases. Y squared is equal to 8x. Okay. So how do you solve a problem like this? They gave you the equation of the parabola. It's like they gave you the final answer of the previous question, and they want you to work backwards. They want you to find the focus and the directrix and also sketch it. So let's see. The first thing you should do is you should specify which standard position it is. So which standard position is this one? You can look at this side and decide from here. This is a positive x. So as long as the focus is in the positive x, as long as the focus is here in the positive x, it means the parabola is going to enclose the focus like this, and this is going to be a standard position number 1. So this is a standard position number 1. In the standard position number 1, we usually have a 4c multiplied by a positive x-axis. and we have here a y squared. This equation looks like this equation. Y squared is there, equals 8x, here 4cx. Now, by comparing these two equations, you can easily tell that this 8 is actually 4 times c, right? 4c is equal to 8. So you can say here 4c is equal to 8. Dividing by 4, then c is equal to 2. Okay, if c is equal to 2, the focus is right here. It should be something comma 0. So it's going to be c comma 0. So the focus is going to be 2 comma 0, c comma 0. The directrix is going to be here. It's going to cut the x-axis. So the directrix is going to cut the x-axis. So it's going to be x equals. Where is it going to cut the x-axis? As long as this distance is 2, this distance is 2, but in the negative direction, so it's minus 2. So it's going to be x is equal to minus 2. So this is the equation of the directrix, and this is the sketch of the parabola. I've done all of them together. So this is these are the coordinates of the focus. This is the equation of the directrix, and this is the sketch of the parabola. And if we really draw it, this is how it's going to look like. You see, the parabola is going to look exactly like what we expected. Sorry, need an eraser. Okay, so look at this. The focus is at 2 and 0. The focus is at 2 and 0. The directrix as at x is equal to minus 2. And the parabola is enclosing the focus. Okay? So I trust that this is also not hard. This time they're giving us the equation of the parabola and they're asking us for the focus and the directrix. Let's do another one. So find the coordinates of the focus and the equation of the directrix, and then sketch the parabola in the following cases. Minus x is equal to y squared. Now they're trying to trick us a little bit in this question. So what they did to trick us is they changed the order of the equation. The equation should not look like this. Y squared should be in the left-hand side, and this is minus x in the right-hand side. So this is a negative x-axis. So where is the focus? Yes, the focus should be on the negative x-axis. So the focus is here. Okay, we know that the focus is here. And the parabola is going to enclose the focus. So this is going to be a standard position number 2. In the standard position number 2, we always have 4c. It is multiplied by the negative x-axis, so minus x. And here we have another letter, the other letter is squared. So this is standard position number 2. Okay? Now, notice that this equation, by comparing these two equations, you notice that the y squared is the same as the y squared, the minus is the same as the minus, and the x is the same as the x. So the 4c is the same as this number, this invisible number here, which is how much? Which is 1. So 4c, 4c alone, without the minus, because the minus is already there. And the x is already there. It's only the 1 and the 4c which are equal. 4c is equal to 1. So by dividing by 4 both sides, we will notice that c is equal to 1 over 4. Now if we found c, then it's quite easy. Now look at this, but concentrate guys. The focus. The focus is here in the negative side, so it is negative c. Negative 1 over 4, comma 0, because it's the negative side. So the focus is going to be negative 1 over 4, comma 0. That's the focus. The directrix is going to be a straight line in the opposite direction. Here, is it cutting the x-axis or the y-axis? It's cutting the x-axis, so it's going to be x equals. And how much is the value of c? It is 1 over 4. Is it in the positive side or in the negative side? The positive side, so we just write it as 1 over 4. So the equation of the directrix is x is equal to 1 over 4. So this is the focus, and that's the directrix, and this is the sketch of the parabola. Now you can look at the exact drawing of the parabola right now. So this is the exact drawing of the parabola. This is negative 0.25, which is 1 over 4, and that's x is equal to 0.25, which is 1 over 4. So that's your focus in the left hand, and directrix in the right hand, to the right hand, and the parabola is enclosing the focus. Let's look at the third example. So this one says 5x squared is equal to 8y. Again with the tricking. Now they're trying to trick us as well again here by writing a number before x squared. I should not have a number before x squared. I should remove this number. I should divide by 5 both sides. The equation should look like this. X squared equals 8 over 5y. Okay, now I'm going to start with the sketching. So, what is this parabola? It's the positive y. So the focus should be here, on the positive y. And as long as the focus is here, the parabola should be enclosing the focus. So the parabola should look like this, and the directrix should be here. So this is at standard position number 3. In the standard position number 3, I always have 4c, right? It's going to be multiplied by a positive y, and here we'll have the other letter, x squared. This is standard position number 3. Now x squared is the same, y is the same, so 8 over 5 is going to be equals to 4c. So 4c is equal to 8 over 5. I don't like to divide if there is a fraction here. To cancel this 4, I would multiply by 1 over 4. And here also by 1 over 4. So divide, cancel the 4 with the 4, you get c equals, cancel the 8 with the 4, you get 2. So this is 2 over 5. So how much is the value of c? The value of c is 2 over 5. Now look at, let's come back to the drawing. So this point here is 0 from x because in the y-axis. And the value of y is 2 over 5. This is the focus. So the focus is going to be 0 from x and 2 over 5 from y. The directrix is going to be in the opposite direction. Is it cutting the y-axis or the x-axis? You can see it's cutting the y-axis. So the directrix is y equals, and do we cut the y-axis in the negative part or the positive part? It's the negative part, so it's minus 2 over 5. So this is the equation of the directrix. Without drawing, it's really hard to solve such questions. This is geometry. And if you don't draw in geometry, then when are you going to draw? You have to draw a sketch so that you can solve this question easily. And this is going to be the exact drawing of it. It's 0 and comma 0.4, that's the focus. The directrix is at y equals negative 0.4, and the parabola is concaving upwards. I hope these points are so far clear. In all of these questions, we have seen parabolas in the standard position. What if they were in a non-standard position? Let me show you this question. Find the equation of a parabola that satisfies the following conditions. The directrix is x is equal to 8 and the focus is 2, 2. Now the first thing you should notice is that is different than the previous questions. Look, if we try to sketch this one, the focus is at 2 and 2, the directrix is at x is equal to 8. Let's do that. So the focus is at 2 and 2. I'm going to draw the focus. So this is the focus. It is at 2 and 2. The directrix is at x is equal to 8. This is the directrix. It's at x is equal to 8. It's cutting the x-axis at 8. Now, where should the parabola be? Look, this distance between the focus and the directrix, this distance now is 6 squares. The vertex should be here, okay, where the circle is. The vertex should be here, because the vertex should be exactly in the middle between the focus and the directrix. And then the parabola should be enclosing the focus. So this is how the parabola should look like. It should be in the middle, and it should be enclosing the focus, and kind of looking like it's going away from the directrix. This is completely not a standard position. This is not a standard position, because we don't have this in the 0, 0. The focus is not on one of the axes. The directrix is not in the opposite direction, so it's not a standard position. How do we solve a problem if it's not a standard position? So first of all, I should say that this is NSP, not standard position. Okay? And this is how it looks like. This is how it looks like when we draw it. The C is at 2 and 2. The directrix is at x is equal to 8, and that's the parabola itself, the one in blue. To solve this problem, I am going to invoke the definition. What is the definition of a parabola? The parabola says that the distance, it's the locus of a moving point. So let's say that the moving point we're talking about is here. This is the moving point, sorry. This is the moving point here. Let's use a different color for this one. So let's say that this is a moving point. This is our moving point right here. What are the coordinates of this point? We don't know the coordinates, so I'll just give it a general coordinate, which is x and y. This is C, this is 2 and 2. This is the directrix, which is x is equal to 8, right? Now, according to the definition, this distance between the focus and the directrix, sorry for the not straight line, this distance, which is here between the focus and the directrix, this distance should be equal to the distance in the other, between the point, here, I'm sorry. This distance between the point and the focus, let's call this D1, should be equal to the distance between the point and the directrix. Let's call it D2. Okay? But how do we find these distances? Where last year, we took two rules that are important for this lesson. We took this rule, which is the distance of 2 points, like this one. Now, this is a point, and this is another point. So the distance of 2 points is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And we took the distance of a point to a line. It's like this one, a point and a line. And we took this formula, d is equal to the modulus of ax1 plus by1 plus c over the root of a squared plus b squared. How do we use these two rules now to solve this problem? Now look at this. We'll write the following. We'll write because d1 should be equal to d2. They're equal because it's a parabola, right? And in the parabola, the distance from the point to the focus equals to the distance from the point to the directrix. D1 is the distance between 2 points. I'm going to use the first rule here, the first rule on top. So how do we do that? So therefore, the square root of bracket x2 minus x1, you will take x from the point minus x from the focus. So x minus 2 all squared plus y2 minus y1, you'll take y from the point and y from the focus. So y minus 2 equals the modulus of ax1 plus by1 plus c. This is actually the equation of the line. This is the equation of the line. But it's this equation, the equation of the directrix. But, however, when you write the equation of the directrix, just make sure that when you do it, you make it equal to 0 first. You don't write it like this. You must transpose this here. So it's going to be x minus 8 is equal to 0. This equation of the line, write it in this place. So it's going to be the modulus of x minus 8 over the square root of a squared plus b squared. What is a squared and b squared? A is the coefficient of x, which is 1, so 1 squared, plus b is the coefficient of y. You don't have a coefficient for y, so it means it is 0 squared. This side, all of it, turns out to be this equation exactly. Why? What is the root of 1 squared plus 0 squared? It's the root of 1, and the root of 1 is 1. The modulus of x minus 8 over 1 is x minus 8. So let's show you this now. So what does this mean? It means that the square root of x minus 2 squared plus y minus 2 squared equals, this is going to be 1, and the only thing that you'll have here is x minus 8 inside the modulus. This is the same as the equation of the directrix. It's always going to turn out like that. So what are we going to do next now to find the equation? I'm going to square both sides. So let's square both sides. If you square this side, you will cancel the square with the square root. You will have the brackets here now. The brackets are squared. You're going to open them using a smiley face. So it is x squared minus 4x plus 4 plus y squared minus 4y plus 4 equals. Now here, you don't cancel the square with anything. You just open this using a smiley face. X squared minus 16x plus 64. All right. Now, this might seem complicated, but it's actually going to be solved now in seconds. Look at this. X squared in this side cancels x squared in this side, because if you move it, it will be minus x squared and there will be 0. So what do you still have squared? You still have squared y squared, right? So start with it, y squared. You have a negative 4x. If you move this now here, it will be positive 16x. Negative 4x plus 16x is plus 12x. So plus 12x. We have a minus 4y. So y squared minus 4y. Y squared minus 4y. Minus 4x and minus 16x has become plus 12x. 4 plus 4 is 8. And if you move this here, it will be minus 64. 8 minus 64 is minus 56, is equal to 0. This is the equation of this parabola. Look at it looks completely different than what we have seen before, because this is not a standard position. So it looks like y squared equal minus 4x plus 12x minus 4y plus 12x minus 56 is equal to 0. This is the equation of the parabola in a non-standard position. You see, there are not too many steps. They're just 4 steps. But you just need to know how to use these steps wisely. I'll show you one more example in non-standard position. The directrix is at y is equal to minus 7 is the focus, and the focus is at 2 and 1. If we draw it, this is how it looks like. The focus is at 2 and 1. You see here, the focus is here. The directrix is at y is equal to minus 7, so it's cutting the y-axis at minus 7. And that's our parabola enclosing the focus. It looks like a standard position number 4, but it's not. So what are we going to do? Again, we are going to assume that there is a point here, and anywhere, and I'll call this point x and y. So according to the definition, the first distance, d1, should be equal to the second distance, which is d2. Remember that this is equal, y equals to minus 7. Okay, I'm going to invoke my formulas that I've learned last year, the distance between 2 points and the distance between a point and a line. And I'm going to do the following. So I'll say that d1, so this is first of all in non-standard position. I'm going to continue with yellow. So d1 equals to d2. This is the definition of the parabola. The first distance should be equal to the second distance. So d1 is the square root of x2 minus x1 all squared plus y2 minus y1 all squared, right? This is the distance between 2 points, equals the distance between a point and a line is the formula that we have there, which is the modulus of ax1 plus by1 plus c. I'm just writing the rules over the root of a squared plus b squared. Okay, so here, what I'm going to do is substitute. So I'm going to substitute. This point is the focus, and the focus is 2, 1. This point is the point that we want to find the distance to, which is x, y. So I'm going to do x minus 2 or 2 minus x. It doesn't really matter, but I prefer x minus 2. So I'm going to start from the point below. So it is x minus 2 all squared plus y minus 1 all squared equals, here don't bother, just write this equation. But when you write this equation, just make sure that you first of all transpose this here. So it becomes y plus 7 equal to 0. Write this side. So what is this side? It's y plus 7. So in the other side, just write the modulus of y plus 7. Don't bother doing the whole formula. It will always end up like this equation. Square both sides. So I'm going to square this side and this side. Here in this side, the square cancels the root and we have the smiley faces. So x squared minus 4x plus 4 plus y squared minus 2y plus 1 equals y squared plus 14y plus 49. What gets cancelled now? You see y squared cancels y squared. So you still have x squared. So maybe I'll finish here. So I'll have x squared minus 4x. I have a positive 14y here. I will move it to the other side. It will be negative 14. With negative 2y, it will be negative 16y. I have a 4 plus 1, which is 5. I have a positive 49. I will move it to become negative 49. So 5 minus 49 is minus 44 equals to 0. This is going to be the equation of the parabola that is in non-standard position. Please try to solve these questions yourselves. Try to practice them yourselves. And for extra exercises, you can look at these practice exercises. All of these are ministry questions. Some of them are multiple choice questions. 5, 9, 17, 18, 21, 24, 29. Some of them are true-false questions like 1 and 13. And some of them are direct questions like 3, 6, 18, 21, 24, 28, 52. Try to solve as many questions as you can, because the more you practice, the more you get familiar to this lesson. And until I see you inshallah next time with the second and the last lesson in this chapter, in which we will discuss further the other shapes, the circle, the ellipse, and the hyperbola. Until then, I hope that you're safe and you're sound, and I hope that you understood everything in this lesson. If you have any questions, please ask me, and best of luck for all of you, and peace.